Okay, so we're live. So we're now going to move to the final discussion. So welcome all you people on the internet who joined us. Thank you for coming. We have a short period of time for final discussion before we go to the open questions. So I'm not a control freak, but you're going to do it my way. So we've tried to organise a final discussion to get to the points. If there's something we've absolutely ignored, then you must speak up. We hope you haven't missed anything. So my beautiful assistant, Chris Moffat, will be timing these, and we've got 5 minutes and 10 minutes for each slide, etc. So we're going to keep as much of time as possible. He's going to set the buzzer and keep us going. So this first one, we can hopefully save some time, because I don't think it's a contentious issue, is what is the field relevant exposure level? So you can see up here we're talking somewhere in the region of low parts per billion, basically, somewhere between 1 to 10 parts per billion. More in pollen, less in nectar, but maybe nectar the biggest issue. Does anybody have a problem with that, or can we just accept that and move on? Is everybody happy?
One tiny comment, that doesn't really apply to folio applications used in horticulture or on fruit crops or whatever, where you usually find clopper or acetamiprid, which do produce much higher.
Okay, yes, good point. So this is, I suppose, systemic exposure. Yes, at the back. Make sure you can speak loudly. So.
Yeah, does it also need to come with the caveat that this isn't the only exposures that these animals are being subjected to? I mean, there are other pesticides involved in the exposure scenario as well. So, I mean, that may be relevant for the neonics, but maybe we ought to make some sort of statement that there are other pesticides that they're exposed to as well, which may or may not need to be taken into account in the due
Yeah, the effect of potential additive or synergistic with disease or pesticides is another issue. This is just so we can agree that if anybody does any studies, if they're using this kind of range, then at least it's credible. It may not be explained everything, but it becomes credible. So can I move on from... No, I can't move on.
I'm a little bit confused about this term exposure. Is it the exposure at the plant, from the plant side only, or is it the exposure of the animal? Because in the moment we move into the animal, we need to talk about doses and not concentrations. And is this included in exposure?
No, this is just what they would have access to, and of course how much they use of it. What other crops they use, mitigation, are all important factors. But it's a question of if they can get this, then at least that's a starting point. But as you say, yeah, you're right. You'll obviously all say that if you're only taking 10% of this and 90% of something else, then it becomes more complicated. Or maybe they're taking more. But at least we can say, are they consuming, or some bees, are they consuming this?
One way of making it more clear, Chris, maybe to make it feel relevant residues.
Right. Okay. So what?
I'll just tell you that's the residues. What you've quoted are figures that are ranges of residues measured in pollen nectars. You just change the title. What are field relevant residues?
Okay. Okay.
That will address the person's problem.
Yeah. Nothing simple, of course. So now these are an important area. We're going to, for the next two slides, are talking about field studies and then lab studies. Now, no study's perfect, and nobody's pretending they are. So we just have to come to some kind of discussion and agreement over what's good and bad about each set. So here's what Joey and I did last evening. We're not saying this is perfect, but the advantage of field is that they're performed on whole colonies, and they're designed to simulate agricultural settings. Okay, so that's why they're considered better. The disadvantages is that obviously it's the habitat, and you can't control the habitat. You don't know everything about what is there. So you have many uncontrolled variables, including the weather, although I think your model is going to control the weather, was it? And we have, it's largely correlational data, so here's what's provided and here's what's seen, rather than mechanistic. And I suppose the biggest argument might be it's relevant to that field, but how relevant is it to all fields? So I suppose I should give you the chance to say, do you disagree with any of those, or do you defend any of these? And then other people, would they like to add? We have 10 minutes for this slide, so we're quite generous here. So can I get... I can't.
Do you count the colonies exposed from inside to the outside as field studies?
Just don't ask me. This is what do we think.
I don't know. Do we think it's because I just wanted to react to your question before, your remark, and I found it really, really important to when a study is conducted with intoxication, exposure inside the hive, then we lose this risk that can, with what you said, that can be taken by the bees when they are going out. And this is what actually Schmuck showed before, that he saw a difference in individuals regarding the homing success with thiacloprid, and he didn't see it with the whole colony. But if the bees are fed from the inside, then they don't go out and they can't get lost. And then they don't go out. I don't say any bee is going, no bee is going out, but the exposure, the risk is diminished. So I don't know if we can really compare and say there is no risk for the whole colony, but for individual bees. Because if we extrapolate the risk for the individual bees to forages that forage on the whole crop, then the risk is there. So
Yeah, that's a good point. So I guess the two levels at which they're working at are quite different. So whether we're looking at individual bees.
That point, please. We didn't quite get all of that.
I suppose the main point is that whatever happens to an individual bee may not reflect what's happening to the whole colony, and also it depends on what your bees have to do while they're being exposed. So if they have nothing to do, the stress might be less than if they've got very high demands. I think, is that a fair summary?
yeah.
Can I just interject, so Chris, the viewers online are complaining that the questions from the audience are completely inaudible. I think we're going to have to...
Okay, so we're going to have to make... Okay, right. Sorry, did we have... So Richard?
Maybe just shortly... Maybe shortly on the technical part, it's not the case that the bees totally remain in the hive. The study design was specifically to stimulate the foraging activity by not supplying them the pollen. So they had to go out and fly for the pollen. And it was not the study aim to see whether we have effects on individual bees when we do the colony studies. It was more the aim of the studies to see whether the effects we have observed on individual bees beforehand is translating into an adverse effect in the colony, not on the individuals in the colony, okay? And so it's a bit more than the correlational data, I would say. This kind of studies at least provide us a good control of the exposure. So, and we have a kind of mechanistic understanding. We can directly relate to the residue level to which the bees have been exposed. And there are also some understandings and some models to translate feeding concentrations into doses.
Okay. I'll bounce back and forward. So, right on.
So maybe I quickly correct what has just been said. It's not true that this study was controlled for no nectar uptake in the environment. This is not true because the animals were allowed to forage at any crop, and it was in a, for example, apple tree colony and so on and so on. And also, unfortunately, there was no measure whether it was the provision of sugar water contaminated was actually taken up. There are no measures of how much of the neonics ended up in the animals, whether they were inside or outside. So this is a very limited study and very selective.
I think I have to give them the opportunity to respond before I come back over.
I assume you just referenced for the study where they used thiacloprid, right?
The last one you mentioned.
Yeah, this was a confirmatory experiment. My experiment, what we have done by ourselves, was of course measuring the consumption rate, and we could be sure that the sucrose solution was completely consumed. You're right that the bees could freely forage, but also said that the landscape hardly provided any nectar source, and it was during a nectar-darse period. It was not 100% control, I agree, but this was the best control of exposure we could conduct. And at least by the consumption rate and measuring the consumption rate, we can say something about the dose.
Thank you. I want to go over. I'm going to come back to you. Sorry. Come over to Jeff Pettis over this side. Oh, yeah, good.
I think we'd all agree in an ideal world that field studies are the real world, but we're always limited by plot size. And I think we can increase the pros by using a different organism. And I talked about using bumblebees. You decrease the flight range. They stay in the crop of choice until you can plant a crop that's treated in a various way and increase the sensitivity. We've been using honeybees for a number of years, and they have a huge buffering ability, and we don't see the effect. So I would, again, we can increase the pros of performing on whole colonies by moving to bumblebees as a better model for colony effects.
That's a good point. So it's not all about honeybees, it's about the insect pollinators. We can't look at every insect pollinator, so we need to find key species that like bumblebees.
Okay, I think it's a very grey area about what is a field study and what isn't. I would split them into two things. I think you have controlled toxicological dosing with free-flying bees, and I think we've seen that as an example. And then I think you have a totally pure field study where you expose the bees to the chemical in the environment. And for me, that's how perhaps I'd have two categories of field studies depending on the dosing.
Right. So how are we doing for timing on this one? Chris, have we still got time?
Another 3 minutes.
Okay, so...
Are there any questions from the online audience that relate to this?
Well, we can do online open questions at the end.
Okay.
So,
all right.
Do we have any other questions? Randolph wants to do one, but I want to give somebody else a chance first. Sorry, Randolph. Dave?
I just wanted to expand a bit on Jeff's point, which, to put it another way, I think a weakness of the field studies that have been performed with honeybees thus far is the fact that, for practical reasons, the plot sizes, the plots of crop that have been grown to put the hives next to are usually far smaller than real fields. And if you put several hives with often 500,000 or whatever honeybees in them next to a 1 hectare plot, most of them will inevitably not be feeding on the crop. And then if you don't find an effect, it's really hard to say whether that's got anything to do with the real world at all.
Yeah, so that's a good point. You can't control the dose that you give. I mean, so I think we can go to Randolph. The other issue is a field study is realistic to the field, obviously, but is it realistic to all fields? I mean, how realistic is it to the general environment? Oh, sorry, I should give you a microphone. Does anybody want to accept that?
It's generally realistic to the crop, and also you select your field study for the crop and the region that you're assessing. So we very rarely just do one field study and say that's typical of all situations. You pick field studies of the typical crop in a typical scenario, and you'll do, if you want more than one region, you go to more than one region. So we never just take one field study and say it's applicable to all situations.
And do you pick different types of fields or similar types of fields?
We pick fields that are typical for that crop. Yeah.
And surrounding habitat?
Yes.
Maybe just a supplemental to what Peter just outlined. Yes, we pick more field studies. We do it over more years. It's not only one field studies on which our conclusions are based. And it will be supplemented also with monitoring studies of a kind I have presented.
Sorry, can you explain the dynamic that's going on? Is this who's being represented by that view as opposed to...
So I suppose
sorry, those of us who've just joined.
We can announce who we are when we ask a question or answer one. So we have representatives here from Syngenta and Bayer. And so yeah, from now on can we announce who we are, so if anybody wants to be prejudiced, they'll have to be prejudiced.
Chris, are you going to give Chris
do we have time for any more?
Yeah, we've got a minute.
Can Chris cover?
Oh, sorry, Chris.
Yeah, just a comment on the exposure in field studies. I understand the comment about bees flying elsewhere and they can choose not to fly on the treated plots. In the study we did, we had 4 colonies in a field in a 2-hectare study, and we actually monitored what pollen was being brought back. And 1 week after exposure, about 88% of the pollen was canola pollen. And our canola plots were the only canola grown in that landscape, so we know they were feeding on our plots, which indicates that the exposure to that treated canola was quite high.
Does that mean they're feeding on it or they're collecting it?
Why would they be collecting it if they're not feeding on it?
Save it.
Yeah, but they're going to eat it.
Yeah.
Peter Kennedy, University of Exeter. The question, as I read it, is limitations and advantages of experimental approaches. Are we not missing something by not talking about the pros and cons of lab studies as well?
We're going to that. That's the next slide.
Thank you.
And with that, maybe we should move to the next slide. Right?
Okay, we're still getting complaints about the sound level, so even us at the front need to use a microphone. So do you want to lead on to
you do that.
Oh, I'll lead on to Okay, so what's good about a lab study, the most important thing, of course, is you control the experiment. You know nothing else comes in, well, reasonably well, to influence your experiment. You can study causative, so you can understand what does this cause that, and what is the mechanism by which this happens. But most importantly, what you can study is sublethal, subtle effects that are hard to see, because you can look at a cellular level or network level, or even just a whole organism in terms of behaviour and learning ability. So these are very subtle mechanistic effects that, although they don't show that the bee dies, they show that it's less good at being a bee. And so the question then is, so what, I suppose we could argue. But lab studies can do these things very well. Is there anything else I've missed about what's good about a lab study? Just wait for the microphone.
Beth Nichols from Rothamsted Research. I think a big advantage of understanding the mechanistic approach and underlying why the bees might be having these subtle effects is that then you can do something about mitigating them potentially. If you understand how the effect is happening, then you can kind of potentially do something about mitigating that.
Thank you. I think it must be hard to argue against the positive parts of lab studies, either in terms of physiology or in terms of behaviour. Probably more important, we'll go on to the disadvantages. I apologise for this. I'm just a bit squeaky.
Okay, I just wanted to comment, looking at this list, that...
Who are you?
Oh, sorry, Sarah Lummis from Cambridge University. That I would have thought that the individual bees or single colony should be a pro rather than a con, that you can decide whether you're looking at the individual bees or the colony in a lab study.
Thank you. Right, we have another question here, please.
Pete Kennedy again, University of Exeter. I was also involved in the development of the Behave model, and one of the things that came clear from the way the model was constructed, that there are very important feedback loops within the colony that may be missed by looking at the effects on individual bees. So there's a certain level of compensation that a colony can do to overcome effects on individuals. And I could see that as obviously a con from the lab studies, that they wouldn't pick up on those feedback loops.
Yes, I mean, I would agree. I mean, the lab studies, well, in fact, unless they're done at a colony level, so it can be done in a lab study, highly controlled, if nothing else, artificially fed, and so then these kind of things can be done in a controlled, relatively controlled environment, as opposed to the field realistic environment where they have more to contend with, arguably. So the disadvantages are quite often it's being done on individual bees or whole colonies. So much of the work of Dave Goulson and Nigel Raine have been looking at whole colonies of bumblebees. There's, in terms of a field realistic exposure, you know, is it realistic? We don't give them a choice because we need to know they've consumed what we want to expose them to so that we can study the effect of that exposure. So therefore that's not realistic, because in the wild a bee would get exposed to other things and it may experience some mitigating factors, which we'll come on to. Is this working? Yeah. And of course it's performed on a limited number of conditions, so there are no other threats. So that's both a weakness and a strength, because you know what the contribution of that threat is to those bees. And if you could do the same to the other threats, maybe a model would then allow you to determine what they'd be together. And experimentally, you could then combine the threats, like Jeff Pettis has put, and others have put in Nosema, Surani, along with pesticides, Ecological. And okay, so question here. Announce yourself.
Richard Schmuck from Bayer. I think I have one pro and one con. One pro is that we better understand and get a better guidance how we design our field studies, because we better understand how such a substance acts and what are the potential endpoints we have to look on. And a con, it's partly a question. I mean, what we are doing in the lab, we are taking the honeybees out of their social context. My question is, does it not increase the stress level to which these bees are exposed and may make these, taking it out from social context, make it more sensitive?
That's a good question. I'll put this out. Maybe a beekeeper would like to comment on the fact that normal beekeeping must be quite stressful to honeybees, because you're coming in, you're ripping the colony apart, you're looking at them, you're cooling them down at regular intervals, you steal their food. So you want to comment on this issue? Okay. Is anybody going to think to comment on the issue of that issue? No? Okay, so we'll move on. Don't forget to announce.
I'm Majrun Lund from Lund University in Sweden. And I actually think that you could take some of the pros from lab studies and think about it in the same way in field realistic studies and control some conditions, replicate it well. You could look at sublethal effects under field conditions. So if you combine the lab studies with the field studies and take all the best parts and combine it, I think you have some good guidance. And I do think that you need both types of studies to make good risk assessments. And we shouldn't forget that we're talking a lot about bumblebees and honeybees, and they are the colony is the reproducing units. It's important to not forget that. And that there are also solitary bees with single individuals that are reproducing units.
So that's an important point of what you consider the organism to be, whether it's a colony or the individual. And
Randolph Menzel from the Free University in Berlin. There is a more general point to the pros and cons. That relates to the kind of experiment you do. When you have a negative result, then it depends very much whether the negative result is compared to something else. Because a negative result usually doesn't give you very much information. You need a positive result, a positive outcome. And so the lab studies are always designed such that you have a control group and you have your experimental group. And only if you find a difference between the control group and the experimental group, you can say you have found an effect, and that is then a data point. Something which is not compared to a control group is not a data point. So the problem in field studies is very often that they have negative results, but they have no control groups. And so they are not providing data points in the strict sense of an experimental design. So I think we should emphasize that the lab studies, by isolating components and factors, they allow to keep the logic of the experiment, namely to always compare a positive result with respect to a control group.
Yes, that's a good point. One other issue I suppose we should bear in mind, okay, I'll come over here, is that pesticides are chemicals. Therapeutic drugs, medicines are chemicals. So they're still actually all just chemicals, and they work in similar ways. And lab studies for therapeutic agents is highly rated. So we just need to bear in mind that lab studies are very important to analyze the risks and benefits of chemicals. So, yes, can I take...
Karl Kreilsheim, University of Graz, Austria. So sometimes the honeybees themselves are preventing us from making good field experiments. So, for instance, if we are investigating effects on the brood, so in several cases, honeybee nurses will remove the brood that we have treated or that were treated. In other cases, they will not. So if we want to see an effect, for instance, on the brood, we have to go into the lab, because otherwise we will have no data or data that are not valid at all. So there are some things you can only investigate in lab experiments.
Okay, well, we still have about a minute, do we, or less? Okay.
So we're hearing a lot about lab, and Galen Dively from the University of Maryland. We're hearing a lot about lab and field studies, but I think we're missing one huge experiment, and that is the ban on neonics in the EU. And to me, that's an experiment. But I haven't heard of any organized effort to evaluate the impact of that ban.
So yeah, that's a. Anybody want to just mention the impact? Actually, that's not really related to the lab study, so maybe we can come back to that. Have you got a comment about? Oh. Okay, so time's up. That's an important point that I think we must come back to. So I think basically we can agree that lab and field studies have a place, an important place, and it's not one against the other, and they completely disagree with each other. So now, an important thing, we do have to use pesticides to produce our food, sadly. There are so many people, we have no choice. So what we have to think about is how can we learn to live with pesticides? And an important point is, can we mitigate against any potential dangers to pesticides? So basically, can we mitigate? Can we provide additional food and home facilities so they can eat and live somewhere and overwinter? And can we improve habitat so they can move from one place to the other safely? Now, this is probably an area that I think we're probably going to all agree on, but I think I'd like to hear us all agree on. Maybe we won't. So can I ask for any industrial chaps to, because obviously you guys are doing a lot of work in this area, so.
Christian Maus from Bayer. Yeah, I agree. I mean, availability of habitat and nesting places, especially for wild bees, is probably the most crucial factor for the existence, for the occurrence of wild bees, of wild pollinators in agricultural landscapes. So I would agree, definitely.
So can I ask you, Dave? Oh.
I'm sure everyone.
Dave Goulson.
Sorry, Dave Goulson, University of Sussex. I'm sure. Sorry about the feedback. I'm sure everyone would agree that more flowers has to be a good thing and will really help wild pollinator populations. Just one small point. Relating to that, we would need to be sure, or want to ensure, that any plants, wildflowers that we grew on farmland weren't themselves contaminated with pesticides of one sort or another. So, for example, if you planted a pollen and nectar mix on a formerly arable field, there would be the possibility that those plants would be drawing up, for example, neonicotinoids from the soil and doing more harm than good. That's speculation, but it's based on a little bit of evidence. But there's a huge knowledge gap there as to whether that's really something that happens regularly.
Yeah, I think that's a really valuable point. So it's not just about providing these facilities. It's a question about where to provide them. So it's something of an argument. Do we have field margins or do we have permanent places? But still we have to think about connecting. So we've got ecologists here, so good if the ecologists can come and speak up. So it's about delivering the food and in the right appropriate landscape.
Majrun from Lund University again. And there are a lot of, in the European context, there are a lot of data showing that closeness to semi-natural habitats like extensively managed grasslands for forage or grazing is essential for the richness of bees in agricultural landscapes, and that the further away you move from such habitat into agriculture, pure agriculture habitats, the fewer bees you find. But it also seems like that you could increase the reproductive output of, for example, for bumblebees by introducing their favorite forage plants. And the clovers are a hot one to introduce into the landscape again. Looking at data from several European countries, you can see that the decrease in legumes have been super dramatic. I think it indicates around 90% decrease in legume forage over the last approximately 100 years.
Okay. So, Dave?
Just point that just occurred to me. We do know very well how to create flowery habitat on farmland, and there are agri-environment schemes available to farmers where they can get funding to sow wildflower strips and pollen nectar strips and so on. But uptake is really, really low at the moment, and I think that's a fundamental issue, is that somehow we need to persuade farmers to do this more, and also explain to them how to do it, and that there are some good initiatives in that area ongoing, but mostly they haven't really had a big impact yet. The actual area of these things in our British landscape is really small.
Okay, so that's a good point. Our ability to deliver is not proven itself just yet. Another issue we should think about is there an opportunity for people's gardens to provide some of this mitigation? Yep.
Thank you. I'm Sandra Bell from Friends of the Earth. I certainly support the last two speakers who talked about diversifying, particularly leguminous crops and increasing habitat on farms. But I am concerned if the view from this conference is that, well, we just have to carry on using pesticides at the current level. I would have thought that with the evidence that you've been discussing over the last 2 days, I would hope that there'd also be some agreement from delegates here that it's really vital that the government actually steps up its R&D into alternative methods of pest control that could actually benefit farmers too. So, for example, just Ian Boyd apparently yesterday said he wants solutions, so here's a couple of suggestions. The development of, for example, oilseed rape crops that are resistant to insect-borne diseases would save farmers money as well as being safer for bees. Apparently there's some interesting research from France showing that companion planting for oilseed rape has not only increased the yield but has also negated the need for seed-coated for seed coatings and also reduced subsequent spraying. So I'd be really interested to know whether the views of the delegates here are that we should also be looking very, very much more at alternatives to pesticide crop control, pest control.
Okay, good. Is there any industrial work going on in integrated pest management as an alternative or addition to pesticide use?
Sure. I mean, Richard Schmuck from Bayer. If it comes to insect-resistant varieties, of course, there is a lot of research going on to develop such varieties. And we also look around constantly for other tools to control pests, including biologics. And finally, what we are doing is to look in a crop cultivation or crop management practice, which was the best one, which is, from an economic point of view, the most viable one.
Thank you. We're running a bit behind, so I'm just going to move on to the question of evidence. So what exactly do we need to provide evidence-wise to show that a particular pesticide is an unacceptable risk? And also, what exactly do we have to show that they provide no unacceptable risk? So these are, you know, is there something we can say that that's what we need to do to decide it? Does anybody want to comment on what we need?
This is May Berenbaum, University of Illinois. Could I just ask for clarification as to what the fate of this document that's being prepared will be, and who's the audience, and what weight will it carry? And that I ask only because, well, maybe it was discussed the first day and I missed it, but that you said, you know, what's coming out of here, or recommendations, but what weight do they carry, and who's the audience, and what street cred will it have? Is there a vote that's going to be taken? Or could we sort of establish the guidelines at this point?
Well, there is no document to come out of this. This is an opportunity to provide scientific debate away from the politics, and so that science can be heard. All right, how widely it gets heard, that's up to some of our journalists here, I guess. Whether we get to vote on it, obviously, what maybe would be quite interested on a vote, because Avaz have done a vote on should we ban these murderous pesticides that are killing our bees, and that's kind of a stacked question, so yeah, of course we do. Maybe what we should be thinking about is, you know, both questions are, you know, who thinks that they're not a problem and who thinks they are a problem? Only asking for those who are concerned. These are people mostly that, yeah, they're concerned about bees. And you've just told me that what they're doing. Of course I don't want them to do that. So if we had a vote, it would have to be a very carefully constructed one so that people had an honest choice to make. And that would be quite difficult, I think. So we have a...
Chris Hartfield from the National Farmers Union. The question you just asked, Chris, is quite different to the one that's up on the slide there, because you talked about the notion of acceptable and unacceptable risk. And I think that's a huge hurdle for probably this whole kind of community, and everyone who's discussing this topic, to get their head around and get over, is this notion of accepting that there isn't an acceptable risk. There is a level of acceptable harm that we can tolerate. I think at the moment, and certainly in the public arena, the view would be that no harm is acceptable.
Yeah, that's right. And Simon Potts was talking to me yesterday, and of course the answer to these questions is it depends who you ask what they feel. Many people would say any harm is not acceptable, as you say, but of course we have to be realistic. And what level of harm do we have to tolerate, I suppose, in order to achieve more important goals like feeding people or producing biofuel? Do I take it then from these questions that we don't know exactly what evidence we need to prove a pesticide is dangerous, and we don't know what evidence we need to prove they're completely harmless? In which case, where are we going? Has anybody got something positive to get us out of this? Oh, hooray.
Maybe the question should really be trying to prioritise what are the major challenges of, facing pollinators. Where do pesticides stack up against all the other issues? And what can we do over all of these issues, including pesticides, to improve life for pollinators? By focusing in on one, which might be, I was talking to one of the speakers earlier today, if you have a boat and it's got a number of holes in it, and it might bring that down, pesticides might be one of them, but if you plug it, and that's the smallest hole, and you've got a bloody great big hole 10 times bigger at the other end of the boat, your boat still goes down.
Yeah, good point. Anybody else?
Randolph Menzel again from Berlin. It's a question which kind of world we would like to live in. And obviously we have a mystery here. We are discussing effects on the level of individuals and the small number of animals, or highly sensitive animals like bumblebees. And we have the situation with the honeybee colony. And there seems to be something which we don't understand. So obviously, from a scientific point of view, we lack data. We do not have the appropriate data. And also we look at a very limited time horizon. We do not look at a time over centuries. If it goes on like this, what does this mean? And so this again calls for additional data, better monitoring on the level of this kind of mystery on the colony level, and then see how we are able to extend it to a larger ecological condition. So I think we need to look over the horizon of just this 1 year or the next. We need to look into a longer period of development in this kind of industrialized agriculture. And I don't think this is just without alternatives. We have alternatives.
Thank you. We're kind of over. So, you still on this you want to talk about? So, I think we need to move on because we have to go to open questions very shortly. So, I think what would be really valuable, maybe document that we could produce or some kind of output from this, is if we could agree on what would our choice of policy change be. What would we most want to tell government that we think? So, some people may say ban all pesticides, but what do we think we can do to make a positive impact to government to help our pollinator insects and habitat? So, Dave, were you going to comment on that or something else? IPM.
It seems to me and many other people that we seem to have forgotten all about IPM. Sorry, Dave Goulson, University of Sussex again. 30 or 40 years ago, everyone agreed that integrated pest management, a philosophy based on minimising pesticide use, was the way forward for lots of reasons, not just for protecting the environment, but actually because it's the most sustainable way to farm. But actually these days we seem to be relying very heavily on prophylactic use of pesticides. I showed some data 2 days ago for a single field in Hampshire of oilseed rape, which was treated with 22 different chemicals in a single year. That doesn't look like IPM to me, and in fact we've forgotten all about the basic principles of IPM, and we need to go back to those. Unfortunately, there aren't any independent, or very few independent agronomists to advise farmers on how to go about doing IPM, and one of the things that I think government is responsible for is it's cut back on government-supported agronomic advice, the kind that we used to have experimental farms that employed researchers that worked on how to grow crops. We don't have that anymore, and we're relying entirely on industry to advise farmers. Hardly surprising, then, that they're using way more pesticides than they need to.
Can you say in just 1 or 2 sentences what you want them to do?
It's something that will never happen, but I'd love to see them go back to funding independent agronomists, state-funded or paid for by farming taxes or whatever. At the moment, farmers are paying agronomists for advice, but those agronomists mostly work for agrochemical companies, and inevitably they have a strong vested interest in advising them to use pesticides. Unless we change that, we're never going to get away from overusing pesticides.
Okay, so we have a question over here. How are we doing for time, Chris? Are we completely out?
My name's John Havison. I'm concerned from what I hear about the increasing pollution of our environment. One of the things we might do is monitor what's going on in some of the organic farms. There's a huge organic estate next to me, and the owner's trying to push the organic message and the success he's having with the non-use of chemicals, and nobody's interested in monitoring what's happening on the land. So let's look at some of these places and compare them.
What are you asking the government to do?
I'm asking the government to start looking at some of the organic organisations and see what the performance of these firms are actually achieving.
Okay, that's a good point. Is there any does industry want government to do anything for them? No, you're happy.
Sarah Lamist, University of Cambridge. Was stunned by Dave Golson's data about the amount of pesticides that are being put on these fields. And I think if the public were aware of this information, then it might put pressure on farmers to actually minimise that. So I would suggest that all this data should be available very easily to everybody so that we can actually just put pressure by knowing about this sort of information.
Yeah, excellent point. So,
Galen Dively from the University of Maryland. Actually, I think we have an opportunity to implement IPM with this ban on the neonics, because if flea beetles are the main pest that these seed treatments are targeted for, then we have the and they occur above ground, we have the opportunity to scout for these flea beetles. There's probably already thresholds developed, and apply foliar treatments only when necessary.
Thank you. So I would like to get on my hobby horse, just to finish this off quickly, is what I think we need to do is to learn from past experience. We need to learn from mistakes. We can't predict everything that's going to go wrong with pesticides or combinations, but the landscape uses several hundred pesticides in combinations that are decided on a whim or on a local need. And these are recorded by European regulations, so farmers have to record how much they've used, where and when, and that information sits on a kitchen table, because the UK government and I guess European governments do not collect this data in, and they have the legal right to do so. If we had that data, we could use that. Our epidemiologists could learn from this and suggest where correlations might occur for honeybee losses and other insect losses. We better be quick, because we are definitely overrun. So,
Matthias Schott from the University of Gießen. Someone was talking about some public pressure on farmers. I think we should have some positive pressure on farmers, so that they get some money or refund if they're not using pesticides, or that they get some kind of insurance when they're not using pesticides and they get some crop loss. So I think that would be some good thing to do.
Yeah, good point. Farmers are not our enemies. They're producing our food. We have industry. So I'm going to have to make this, sorry Chris, I'm going to have to make this the last one, because we have open questions, so you can.
British Smoke from Bayer again, because you just challenged me what we would like to the policymakers to do. Just one word on one element which is very important for us. I mean, we can agree on all kinds of future agricultural paradigms, but it can't come tomorrow. I mean, for us, we invest heavily in innovate what we have as a tool to protect our crops. And what we definitely need from the policymakers is predictability. Otherwise, this innovation will not come.
Okay, that's a good point. I think at this point, we should now go to open questions. So we'll take questions from the audience and also as they've been coming in live. So, Joey, would you like to start by taking some questions while I can see what we have coming in online?
I mean, I think one of the main concerns the public has here is come in is they want you to justify the assumption that we need pesticides to grow food. There's quite a few people.
Okay. All right, so the public is asking maybe that the onus of proof on us to show that pesticides are affecting bees isn't fair, and that actually what we need to do is to first justify the use of modern agrochemicals to produce the foods that we need. And so is that really the question? What proof is there that we need to use as much pesticide as we are?
Yeah, I guess we need to justify the use of pesticides, is the question.
I think the population statistics answer that question. We have a growing world population, and you've got choices to make. And if I think that the predictions that you need to, the population is going to reach 9 billion by 2050. You're going to require either more food from the same land or more land to produce the same food. And if you go for the extensive model, which is more land to produce the same, more food, you're going to have to have a biodiversity and environmental impact on yourself. So, this pesticides are really important to actually deliver, the food that people need. And it doesn't have to be a one or the other. In Syngenta, you heard what Jeff Coates presented yesterday in Operation Pollinator. If you manage some of your land for biodiversity, for the environment, you can do a great deal of benefit. And then you might leave other parts of the land which you manage for productivity to feed the growing population.
Okay, that's a good point. The other issue is, I don't know if anybody knows the figures, but how much of our food do we throw away? So how much increase in yield is necessary? Anybody know the answer to that? Could you wait for that?
Of our food is 40 to... You want to say?
Sorry, this was taken from The Guardian, so I don't know how accurate the figures are, but they speculated that... they said that 40% of food was thrown away in the UK.
Okay. Leah, do you have a comment?
Yeah, it's also Leah Tison for University of Berlin. It's about this, and I think when we say we don't produce enough and the population is growing, and I think we should look at the waste there is. And I think it's not about that we need more land or we need more efficient pesticide to have more, to produce more. We need to reconsider our system and the consumer also. I mean, we have to get to the public and say, okay, I mean, why the consumer would not take an apple which doesn't look nice, or and this is not just about the farmers and the companies. This is also about the consumers. That this point of view has to be changed.
Can we take one from
Chris Hartfield from National Farmers Union. A couple of things. I'd just quickly like to kind of dispel this myth that farmers and growers use pesticides on a whim. That might happen if these guys up the front here gave the stuff away, but actually they don't. I mean, they have to invest millions in it, and they charge a lot of money to farmers and growers to use these products. So they are an expensive resource, and so they aren't used on a whim. And the other thing is, it's kind of picking up on something the last speaker said. It's about, why proving this point of why we need to use pesticides. Well, you only really need to walk down your supermarket shelves and look at the amount of product that is there that is produced using pesticides. And I think we have to take a bit of a sense check about actually whose responsibility we're talking about here. I think we need to get the public to wake up to their responsibility. If they want a safe, affordable and reliable supply of food, what the current realities are, in order to provide that to them.
Okay, I'd like to go to another online question before we move back over here, because it's quite a cutting one. Is it acceptable, and I guess this is directed to you guys mostly, is it acceptable that we're trying to decide whether neonics are safe more than 20 years after they were licensed on the basis of untrue data? So I'm just reading it. So I suppose the main point is, why 20 years, I suppose? Why 20 years?
Neonicotinoids are safe. They've been a huge amount of data has been generated by industry, laboratory studies, many field studies, many countries of the world. They've been evaluated by independent regulatory authorities time and time again. And even the ban we see in Europe was not supported by all member states. It was a very politically driven decision.
Okay, perhaps I could ask Nigel, do you think that sorry, I don't want to put you on the spot, if you think that the current safety testing procedures is adequate to pick up the kind of impacts that you saw on whole bumblebee colonies, do you mind answering that?
Nigel Raine, Royal Holloway, University of London. I would say one of the issues about the 20 years, which is the question that was originally asked, was that these are a relatively new class of pesticide. Obviously, 20 years isn't that new. But we're using perhaps a one-size-fits-all sort of pesticide regulation or safety testing regime, and pesticides are not the same. So there are different classes of pesticide, and they're used in different ways. So these neonicotinoids are generally used as systemic seed treatments. They aren't the first systemic pesticide to be used, but much of the safety testing seems to be focused primarily on foliar applications, or that kind of topical application, which is a different mode of exposure for the bees. You asked a question specifically about the work that we've been doing on bumblebees. There are differential toxicities to different bees. That's clear. We don't know fully the extent of this, but bumblebees are differentially sensitive to certain toxins compared to honeybees, where most of the testing work has been done. And that's not the fault of the agrochemical people. They've passed the tests that have been set for them, so we need to question whether the safety tests we're using are appropriate. I'm not saying they're not. I'm just saying we need to think about that critically.
Thank you, Nigel. Actually, I'd like to just ask somebody else here, Sarah Lamiscombe. So the use of neonicotinoids has taken 20 years. So as a pharmacologist, looking at an agent that worked on a nicotinic acetylcholine receptor in an insect, is it totally surprising to you that it might have a negative impact?
I mean, I'm very impressed with the high selectivity of the neonicotinoids, I have to say. But I am not surprised that these are going to have, effects on a whole variety of other species as well, knowing actually where they act and how common. I mean, obviously, nicotinic acetylcholine receptors are pretty much universal in the animal world, so they're going to have some sort of effect.
Yeah, so I suppose we can't really answer that. It is a new type, but perhaps pharmacology could have actually been advised, if they realised, they could have actually been on top and said, oh, perhaps that would be a risk. So we've been slow.
Yes, I have a question this is from the online audience, and again, just to clarify for everybody listening in on this, and including the journalists, what IPM is, Integrated Pest Management. What is that? What is it? And can you give a little more information about that? Is there anyone?
Hi, Dave Goulson, University of Sussex. IPM has been around for 40 or 50 years. Integrated pest management is a way of managing pests based on the philosophy of minimising pesticide use, of using pest-resistant varieties, using crop rotations, encouraging biocontrol agents to control your pests. Okay, start again. Integrated pest management is a philosophy of minimising pesticide use by using pest-resistant varieties as much as possible, using crop rotations, which to some extent we've forgotten about, trying to encourage biological control agents, the natural enemies of pests. And it's also a really important point is it's based on monitoring pest problems and only using your pesticide when the pest problem exceeds the economic threshold. Not just when you find one aphid on your crop, but when you get so many aphids that actually it becomes cost effective to use your pesticide as a last resort. And that's the problem, in my view. At the moment, we've forgotten about that. Almost all pesticide applications in the UK on arable crops are going on prophylactically, and seed dressings are a classic example. They have to go on before the plant is even in the ground. So you can't possibly know if there's going to be a real pest problem to control later in the year. So for me, prophylactic use of seed dressings is the absolute antithesis of IPM, and is something we should move away from as quickly as possible.
Hello, I'm Elizabeth Heaster from Client Earth. I just wanted to add that there's been a lot of discussion in this session about approval of pesticides under the Plant Protection Products Regulation, but there is a huge other piece of legislation which is applicable in all member states, including the UK, which is the Sustainable Use Directive, and that requires member states and the government, that is, to come up with plans to reduce use of pesticides, and that includes IPM and all these other things which might help in mitigation. So I think it's really important to realise that there are mechanisms out there which the UK government should be implementing.
Okay, thank you. I have another online question that I think I should read out from one of the watchers. It's another uncomfortable one, I'm afraid. Is there any remaining value in peer review studies when DEFRA, National Bee Unit and the US EPA simply ignore them and cite industry-funded studies? So basically, is there any point having the other studies? Is that a question? So
it's not on. No, it is on. Jeff Pettis from the USDA. I think the value in these studies, EPA, I'll speak for EPA, Environmental Protection Agency. For it to be a core study, it has to be done according to GLP. Most of our independent research is often not done to those standards, but they don't totally discount them. They take them as additional evidence, and they consider it in this weight of evidence. So I think it really is important that we have independent research, even if it doesn't rise to some of the standards of EPA or DEFRA. So I think they do consider it. May, did you want to comment? Yes.
Well, EPA is in a very difficult situation. You look at this in the grand scheme of things. Toxicity testing was developed primarily to evaluate non-target impacts against non-invertebrates. So it's kind of an inversion to try to figure out how to test the safety of toxins that are designed to kill insects when the non-targets are insects themselves. So it's this, and layer on top of that the fact that you're working with eusocial species, where standard toxicity tests, LD50 or LC50 tests, have no meaning. This is a discussion the last couple of days that what does it mean when a single bee dies? We don't know. I mean, if a single caterpillar dies, you know that one will never live to have posterity. But workers are sterile in the first place, so it's a whole and the behavior is different. So we have decades of standardized testing that's been accepted in the multiplicity of contexts that simply don't apply to particularly eusocial non-target hymenopterans. So it's hard to know where to draw the standard. And to suggest, I did a survey of literature citing CCD, over 300 papers, none of which are published from primarily industrialized. There's an enormous body of literature that influences the Environmental Protection Agency decision-making, both directly and indirectly through the public. So of course there's value. A very cynical question to suggest that EPA is again in the pocket of industry, or and for that matter, anyone who suggests that there may be other considerations is automatically in the pocket of industry as well. The thing about the comment earlier pesticides, one reason there's so much discussion on pesticides, it's something we can immediately act on. We can't magically cure viruses in bees. We can't even magically cure them in humans. But it's clear that the numbers of pathogens being detected in bees, just this past week, a new pathogen was detected in bees. So again, we've heard discussions of how pesticides impair immunity and leave bees susceptible to diseases. Well, it's a chicken and egg thing. If there were no diseases, then the pesticides wouldn't have that kind of impact. So it's really important to look at pesticides, and I'm no fan of pesticides. I mean, and as I said yesterday, EPA, IPM, acronym. 1959 actually was when it appeared in the literature, and the driving concept behind it was not strictly to minimize pesticide use. It was to take into consideration factors other than traditional economic factors, including sociological factors and ecological factors when deciding on a course of action to manage pests. So I agree completely with Dave Golson that these other considerations seem to have been lost in the last 50-plus years. And it's to the detriment of everybody, because this prophylactic pesticide use is going to reduce the efficacy of these eventually because of the evolution of resistance and accumulated non-target pests. And I've totally overstayed my welcome here.
But a very nice summarization of the important points. Chris, do you have another question, or Damien?
Hi, I'm Damien Carrington. I'm a journalist at The Guardian. I actually just want to repeat the question from the gentleman from the University of Maryland, which is, with the moratorium on the use in the EU, are we going to be any further forward in 2 years' time, either in terms of knowing the impact on pollinators or indeed the impact on crop yields?
That's a very, very good question. Dave Gorson, would you like to kick off? We're not over there.
Very shortly, I don't think we will be much wiser. I find it really odd that they've brought in this ban but seemingly not funded any program of monitoring of pollinators. There isn't really any monitoring going on at all in the UK or really elsewhere. A little tiny bit for honeybees, but nothing for any of the wild species. And crop yield, as I explained 2 days ago, is only really 2015 when this ban will actually effectively be enforced, because the crops covered with neonic seeds were sown last autumn just before the ban. So this year will be business as usual. The ban will really come into effect for 2015, which is the year it expires. If you looked at crop yield in 1 year, it wouldn't really tell you anything very much, because crop yields vary from year to year all the time. So until someone does a multi-year field trial of plots with and without these neonic seed dressings, we won't know the answer as to how much how big their economic benefit is.
Okay, let's go to...
Yeah, and can I just add to that? Sorry? Oh, so I'm Richard Gill, Imperial College, London. If I can just add to that as well, is the other problem that even if there was this 2-year ban, if you want to look at population dynamics, that is not enough time for there to be a selective force to actually change that population dynamics. And there is always a lag. So even if you did fund it and you did look a lot of those population dynamics, you're probably not going to detect it. So we just need a bit of longer time.
Okay, I have a comment over here. Can I come back to you in just a sec?
Chris Hartfield from the National Farmers Union. I think we like the idea of using the 2-year restrictions that are currently in place as this kind of big Uber experiment, potentially. But I'm just going to throw something out there. Perhaps we've got an even bigger experiment. If we look at what's happened over the last 20 years since neonicotinoids have been introduced. There's a really interesting paper published last summer by Luisa Cavaliero and a group of international scientists, researchers, there's probably some of them in this room. And what that paper showed, actually with respect to the UK, if you looked at pollinator populations, their declines actually slowed over the last 20 years, over that period which neonicotinoids have been introduced. And in fact, for wild pollinators, so make up our bulk of solitary bees and things like that, their populations had showed some increase. So, There's a real disparity there. I mean, for some reason that paper wasn't reported at all in the national media. I can't think why. But for me, it was a fantastic piece of work, and it showed that actually... But there's a chink of light there that we've been doing something right over the last 20 years, and the suggestion in that paper was agri-environment measures.
Thank you, Chris. And I have a question over here.
Just a point of clarity, actually, it's not a 2-year ban or a 2-year moratorium, it's a minimum of 2 years. So at the end of the 2-year period, it's going to be turned back on again. 2 years is when we can submit more data to apply to get our registrations back. So I well suspect it will be longer than 2 years. Okay. Now, what I will say about you asked about monitoring, we would really welcome some independent monitoring during that period. I'm not sure it's going on, so Bayer and Syngenta are actually collaborating, and we're doing some monitoring on winter oilseed rape in 5 different... Well, the plan is, it's very early stages, but the plan is to do monitoring for the next 3 years in 5 different countries in winter oilseed rape, comparing with and without neonics. But we would welcome some independent monitoring too.
Okay. Just in response to the thing about bee population stabilising, which is absolutely true apparently, but if you look at RSPB's State of Nature report that came out last year, which surveyed population trajectories for all wildlife groups, the overwhelming picture was incredibly bleak. So butterflies, moths, beetles, farmland birds, all declining, many of them very rapidly. 1 or 2 exceptions, but the overwhelming picture is actually pretty awful and suggests that British farming is not all rosy as far as wildlife is concerned. I should also add that in the last 20 years we've spent a lot of money on agri-environment schemes in farming which didn't used to be here. So we might well expect populations of things to actually be increasing at the moment. So the fact that most things are still tanking suggests that there's something badly wrong, if you ask me.
Can I just extend Damien's question? And you're saying that it could be for longer than 2 years. So if we apply Damien's question now to 5 years, will we learn anything from a 5-year moratorium?
Well, if we monitor, yes.
Very good. Okay, we have some more.
There was one other question. One question from the audience, the online audience, was can any of the attendees at this conference comment on off-target effects on other animals that may be exposed to neonicotinoids in water or in soil? And how much is known about the off-target effects of neonics on other animals besides bees? Are they just a canary in the coal mine? Anybody willing?
I mean, very quickly, if we apply for an authorization, it's of course much more than just to show effects on honeybees or in pollinators. So we have to provide a full data set also on aquatic invertebrates, on vertebrates, on non-target plants, and on soil organisms. And as I say, more or less are subject to the same consideration and to the same risk assessment procedure as we just discussed for pollinators.
Hi, I'm Vanessa Amaro-Rogers from Bug Life. I know a little bit of data about aquatic organisms, and you're right, they do sort of test neonicotinoids on a certain number of sentinel species, but from the data that's available, the species that are tested is Daphnia magna and some other sort of, I think it's an oligochaete. And there have been some studies that have come after that showing that Daphnia magna is actually one of the least sensitive aquatic organisms to neonicotinoids. So things like gammarus, other types of sort of crustaceans are significantly more sensitive to neonic pollution and in terms of toxicity. There's also been a number of studies on sort of field studies on the levels of neonics in the water. There was one published last year in the Netherlands which showed very, very high levels in the surface water. In some cases, the levels were so high that they were actually able to be applied as an insecticide in themselves. So I think that there is, and I know that we don't do any monitoring for water in the UK. It does take places in other places, but I think that's something that we really need to look at, and it needs to be the next question that's addressed is, what are the effects on the aquatic systems and also in soil invertebrates as well. Again, not a lot of information on soil inverts.
Yeah, I'm David Spurgeon from the Centre for Ecology and Hydrology. I don't think it's true to say that there's been no measurements of neonicotinoid concentrations in water in the UK. There are monitoring programmes around, and there are measurements made. Some of those are academic. Some of those are from industry and government and agencies. Also, the thing about the exposure route is the systemic exposure route is a less likely pathway to reach water than sort of foliar applied pesticides. So I think that, you know, some of the models that look at pesticide runoff, I'm not sure how well they work with this sort of systemic application for neonicotinoids. As far as soil invertebrates go, there are a range of tests out that have been done, and there's a database probably of about 100 or so studies at a guess that have looked at effects on a range of species, and there is things on behaviour, so there is data and information available to start to make a risk assessment from. So there is tox data from independent, from academics and so on around.
If you do have any data about monitoring in water systems in the UK, we've contacted the government, we contacted the Environment Agency and asked them if they were doing any monitoring, and they said no. So if you do know anybody else who's doing monitoring, then we would be really interested.
We're at the point of starting to develop methods to do that kind of monitoring as well.
And also, although they're not supposed to sort of leach into water systems, there are a number of countries, like California has really big problems in terms of neonics in their water systems. There was a study recently in wetlands in Canada where something like, I don't know the percentage, but a very high percentage of the wetlands were highly contaminated. So there is the potential there for problems.
Galen Dively from the University of Maryland. In the States, there's been a number of studies of non-target effects of the seed treatment neonicotinoids, including studies that have been done in my lab and my students. We do see effects on soil mites, collembola, and also certain species of carabid beetles, ground beetles, but they're relatively short-lived effects, so they do seem to recover pretty quick.
Okay, Sandra Bell from Friends of the Earth. Just going back to this question of what should happen during the 2-year, 5-year, however long it is, ban. We certainly think that instead of waiting, certainly the government should not be waiting for 2 years or 5 years to decide on its approach. And surely the rational approach would be to invest in exactly the sort of IPM tools that Dave Goulston mentioned, to spend some of it's just put £160 million of public money into an ag tech strategy. We want to see it spending some of that on R&D, which provides safer alternatives to neonics. That could be better threshold monitoring. It could be resistant varieties, which we know that talking to farmers want that because it saves them money as well. And just to flag up that there is, in the next few weeks, we're going to get from the government a national pollinator strategy with a 3-month consultation period. So this is an opportunity for everyone to make these points to DEFRA and tell them we need proper independent advice for farmers and a lot more R&D into alternatives to pesticides that maintain yields as well.
Okay, I'm going to take another online question here. It should be very quick because it asks, are there any studies considering the effects of multiple pesticides in sublethal doses on native and commercial pollinators? Well, of course, in the UK, the Insect Pollinator Initiative have funded our projects with Nigel Raine has published studies using interactions of different chemicals. Jerry Wright has done it on behaviour of honeybees, so that's bumblebees and honeybees. And we've been looking at a physiological and cell biological level. And we're not alone. There are several people looking at interactions. Of course, it's a huge question. But, yeah, it is being looked at. So thank you for the question. So do we have any other questions here? Because I've got another one. Nigel? No?
Nigel Raine, Royal Holloway, University of London. Thanks, Chris, for flagging up our work. But we're looking at impacts of combinations of chemicals. That's very important because it opens up the wider question. We're focusing very much on neonicotinoids and use of pesticides. Clearly, if we are going to move away and use less pesticides, that's great. And during the moratorium, there's the obvious issue. You can't just remove a class of pesticide and expect farmers to suddenly not protect those crops, so they're going to be using other types of pesticides. And it's not clear to me that we have
appropriate evidence to show the safety or otherwise of the other forms of chemistry that may be older. They may have problems as well. So it's not just removing neonicotinoids. That's potentially a low-hanging fruit to look at, but I think we should be looking in the round at the other pesticides and considering this kind of general stress level in the environment, both from agrochemicals, so not just pesticides, neonicotinoids, pyrethroids, other things like that, but also the miticides we're putting into honeybee colonies, the fungicides, herbicides we're putting on, but also how they're interacting with the other stressors. We've highlighted these mitigations and how we can improve the general habitat quality for bees and other non-targeted species that might be affected, thinking about how to make their lives easier so that they may be more resilient to things like pesticide impacts.
Okay, thank you, Nigel. I have one question here which I'm planning to save as the last question. Do we have any other ones? Okay, so are there any other questions before I go to this one to wind this up? So this question is basically, should we concentrate on organic methods and develop GM responsibly so we can remove chemical use? So should we concentrate more on organic and the use of genetically modified crops as an alternative to chemicals? Has anybody got a choice there? Jeff Pettis is going to have a go.
Jeff Pettis from USDA. I think there is this issue of feeding the world, and I think actually we're going to need all types of agriculture. We're going to need some crops grown on huge scale, economy of scale, I think of wheat and corn, things like that. But fruit and vegetable production in particular can be more local, more, shorten the supply chain. So I think the answer there is things like more integrated pest management in certain crops and looking for alternatives. Organic can certainly be a big part of that. But I actually think we're going to need this total balance to keep going forward. And I really do think that there's certain crops that are always going to have this economy of scale where you have to grow it on a large scale. But there's many other things that we can grow locally, produce and consume locally. And that probably lends itself to more organic production. And just lastly along this point, there has been a huge reduction in the States and here as well in extension efforts and working with the farmer, having independent advice. I think that's really hurt us in the long run.
So I suppose an important question is, can organic farming feed the world? So I don't know if we have anybody to say they can or they can't. Obviously, if they can, why are we using chemicals? So presumably the answer is that they can't. Does anybody have an answer to that?
Very quick one. If we wasted less food and didn't eat as much meat, we could easily feed the world with organic food.
Okay, that's good.
And also if we didn't put the land down to growing biofuel to run cars and machines.
Okay, we have another question back here.
Galen Dively, University of Maryland. I actually work with organic farmers, and I do a lot of evaluation of organic insecticides. And there's actually a movement now in the U.S. to develop new active ingredients for organic growers. And I will tell you that organic farming is done with pesticides. And the majority of, we get about 80% of our organic produce from outside the U.S. We cannot supply our demand in the U.S. It's coming from large farms in South America. A lot of our big farms in the U.S. are applying pesticides at about the same rate as a conventional farm. They're organic pesticides.
Right, so organic pesticides different to pesticides?
Some have the same. Many of them have the same mode of action as a conventional insecticide.
So what's the difference?
They're organic. They're from nature. So they're extracts of plants or toxins from bacteria that are natural. But the mode of action and the chemical is really very close to what commercial farmers are using, like pyrethroids.
Yeah, well, there are many, many natural toxins I don't want to get anywhere near. So I don't think we should make a distinction necessarily about where they come from. It's about what they do that matters.
Just briefly, just to make the point that obviously organic farming is based on, yes, they do use some kind of more naturally based pesticides, but the whole philosophy of organic farming is based on avoiding the presence of pest and disease in the first place, so hence a lot more use of crop rotations, etc. The same sort of principles that could be much more widely applied through IPM techniques as well. So the whole emphasis is on reducing that need for inputs. And just somebody mentioned, you mentioned the original question about GM being a solution. Well, there's no evidence that I'm aware of that GM crops have really reduced reliance on pesticides, so that's not a solution. To go back to the point about IPM, about resistant varieties of crops, trap cropping, there's just, I could list huge numbers, I'm sure you're all aware of techniques and alternative technologies that could be used to reduce pesticide use without going down a high-risk route of GM crops.
Does anybody disagree? Does anybody think GM crops can help us reduce our pesticide use? No? So industry's not particularly buying it either. And of course, when it comes to GM crop, of course, I think it's really bad to bung them all together. There are lots of different types, and each one has to be discussed and considered independently of all the others. So that's the one thing I would say. So, do we have any other outstanding questions, or shall we have one back here? So, let me just come back to you.
Hi, I'm Pete Brotherton from Natural England, and I've only joined this last session. You had on the slides the question, what do we need to do to decide whether pesticides have harmful effects on pollinators? That rather leads me to the conclusion that this conference hasn't provided that evidence. Is that the case? Because we didn't get that summary, those of us that came into the final session. Could you not agree that those harmful effects exist? Or what led to that question?
Well, what led to the question really is any evidence either for or against pesticide damage risk can always be criticised for the fact it doesn't prove that's the responsible cause of insect declines, because it's very complicated. There are so many things going on. It may be one hole in the boat. We don't even know how big a hole it is, if it's tiny or if it's huge. These questions are huge, enormous landscape questions that probably are economically not possible to achieve, is what I would say, I guess. And I'm not an expert, I'm a neuroscientist. So, we couldn't basically come up with an answer. We don't know what evidence would actually clinch the answer to any pesticide one way or the other, I think. Was that what we generally thought?
That even industry, I don't know if you were here for Richard Schmuck's talk, even industry recognizes that neonicotinoids are insecticides and they affect bees. So they do affect bees, it's just to what extent do they affect bees in the natural environment? That really seems to be the key question. So we know that they have an effect on pollinators. We know that they're detrimental. They cause mortality. They have sublethal effects that affect behavior and therefore mortality. But the question is, again, and help me out here, audience who's been studying this, really, how much of this, neonicotinoid is present, and how much does the neonicotinoid which is present then push pollinators into a place where they can't recover?
Peter Campbell from Syngenta. I have got to put a bit of clarity on what your statement was, Geraldine. A lot of the evidence that you say that insecticides do harm pollinators are nearly always based on laboratory studies where you force exposure. And the question that we're trying to address is, does that happen in the real world? Yeah.
So I suppose, are we going back to where we came from in the beginning?
Sorry, Chris, could I just make one point I have to say I'm a lawyer, so I'm asking different questions. I think the big question is, what is this evidence about and who is using it to prove what? and the discussion in the past 10 minutes that seems to be putting the burden on the scientific community to come up with something which you're sure about, which I don't think you generally do. So my question would be, whose responsibility is it to prove that these things are safe? And my understanding of the regulation is that it's up to the person who is putting forward a substance for approval, which is not the scientists.
Any comments? Sorry, May.
May Birnbaum, University of Illinois. A pedantic point, science doesn't prove things except in the theoretical physics concept. The way strong inference works, experiments are designed to fail to disprove. Probabilities are used to determine how reliable the findings are. So our p-values are never 0. They're less than 0.05. And it's all acceptability of risk even within interpreting scientific data. So it's just a point of clarification. Nobody's ever going to prove safety because their scientific investigation is not designed to prove things. There's always some alternate explanation. There are uncontrolled variables. Just want to make that point.
Thank you. That's a very important point. And also on top of this, that scientific knowledge is a slow incremental process that moves by consensus. It's not one study that just proves everything and shows that's the issue. Actually, there's lots of studies that people move with on a consensus of opinion based on probability. But of course, that's a very slow process and it could take a long, long time. And if you want to make judgments now, then really somebody has to take the scientific risk from all of the studies and evaluate it in some kind of way. And of course, when it comes to, Ian Boyd spoke from on a DEFRA's point of view, is that there are other things to consider. There's the need to feed people, there's economic issues, other big problems. So sacrifices have to be made, and they've got to try and assess which sacrifices we should make on the basis of our best available scientific evidence. So all we can do as scientists is produce our best possible evidence, and I guess we have to then expect somebody to use it intelligently. And we'll all disagree on whether they do or not, obviously. So at that point, shall I wind up now? Are we all not happy, but are we all done?
Can we let...
okay, we have...
Sorry, one quick one. This endlessly repeated claim that the only studies that have found negative effects of neonics on bees are lab studies. Well, for one, I just want to repeat the fact that almost every great discovery in biology was done in the lab. There's nothing wrong with lab studies. This dismissal of lab studies as somehow inferior is ridiculous. But also, some of the studies were performed either largely or entirely in the field. I talked 2 days ago about studies which were done in the field. A Kieranalysis study I mentioned, which was done 100% in the field, totally natural exposure, found negative effects of neonics. So that statement is both misleading and untrue. Thank you.
Thank you, Dave. Well, I'd like to thank everybody here and online for your questions. And it's particularly important that it is a fantastic situation where we have industry and we have academic labs, both with evidence for and against, and we're actually here discussing scientifically the case, and we can't obviously agree on everything, but there are areas that we do agree, which is fantastic. So entering the scientific debate is absolutely the way to go forward. Science must be heard. And we mustn't let politics be the only message that gets out there. Science must have its say as well. So I think, thank you very much for having your scientific say and contributing to this important issue. So thank you very much for coming.